My dear students, Assalamu alaikum. Today we are going to start the new topic, maximum and minimum values of a quadratic function. Maximum and minimum values of quadratic function. The general form of a quadratic function is x is equal to ax square plus bx plus c. This is the general form of a quadratic function. F of x equal to ax square plus bx plus c, where a, b and c are constants. This a, b and c are constants, but a will not be equal to 0. A, b and c are constants. A, b and c are constants, but a is not 0. If a will be 0 here, then this equation will not be the quadratic equation. This function will not be the quadratic function. Due to that, coefficient of x square is not 0. In a is not 0 here. Graph of the quadratic function is called parabola, and its shape depends upon value of a. This value of a, that is the coefficient of x square. How we can draw the graph of this quadratic function? That depends on the value of a. Graph of quadratic function in xy plane, here also in xy plane, it can be like this. The parabola can be like this or like this. These two types of shape can be there. Okay. When graph is like this is the minimum point. This one is this turning point, and here one is this turning point. These two are the turning points. Okay, these two are the turning points. This point we can say minimum point, and here this point we can say maximum point. This is the maximum point. Okay, this minimum and maximum point depends on coefficient of x square, mean a, depends on a. When a will be positive, mean a greater than 0, then we will get the minimum point, and the shape of quadratic function graph will be like this when a will be positive. When a is negative, a less than 0, then that turning point will be the maximum point. Shape of the quadratic function will be like this one. Okay, when a is less than 0, mean negative, then turning point is the maximum point, and when a is positive, then turning point is the minimum point. Okay, from this point we can give the lowest value of the function also. Lowest value of the function from this point, and from this point we can get the maximum value of the function, mean the greatest value of the function we can get from this point. After that, to do all these things, we should know about the completing square method. We should know about completing square method. You are already familiar with algebraic identities, a plus b whole square and a minus b whole square. A plus b whole square and a minus b whole square. These are two algebraic identities. Okay, is a plus b whole square is a square plus 2ab plus b square, and a minus b whole square is a square minus 2ab plus b square. These perfect squares are equal to these two. Okay, here how we can make any algebraic expression into perfect square. How we can convert? Suppose here we are taking here one example. Any example we can take here. Suppose x square plus 10x minus 3, x square plus 10x minus 3. How we can make here the perfect square? As this side we will form this side or this side. Okay, as here a square is already here x square. At the place of a we are taking x. Then after that, if here is positive sign, then you can take plus. If negative sign, you can take minus. Okay. After that, 2ab. 2 is from the formula a. A we already have taken x. B what we will take here. B depends on this number. B depends on this number. As here is 10. Okay. How we can make this number 10 here? Okay. As there is 2x already we have here. Then if we will take b5, then it can be 2 5s are 10x. Then it can be 2 5s are 10x plus b square. B as we have taken here 5, then b square will be 5 square. This minus 3 as it is. Now here we can see this x square as it is. 2 5s are this 10x as it is. This minus 3 as it is. This 5 square is extra here. This was not available in the given this quadratic function. This is extra, this 5 square. Okay. As this is positive 5 square plus 5 square, then to balance this function, we will subtract 5 square also. As we are adding by ourselves, then we have to subtract also the same value. Then up to here, a square plus 2ab plus b square. This is a plus b all square. A here is x and b is 5. Then after that, this minus 3 as it is minus 5 square, 25. Then it will be x plus 5 whole square minus 3 minus 25 is minus 28. In this way, we can make the perfect square. This is the way to make the perfect square. For the quadratic function, f of x is equal to ax square plus bx plus c. For the quadratic function, ax square plus bx plus c is written in the form f of x is equal to a into x minus h whole square plus k. We are writing in the form a into x minus h whole square plus k, means we are making perfect square of ax square plus bx plus c. Here this hk are the coordinates of turning point, mean coordinates of maximum or minimum points is the turning point. Then this turning point, how we can know that this turning point is maximum point or minimum point? If this coefficient of x square, this one or this one, a, is negative less than 0, then turning point mean hk is the maximum point. Is the maximum point. And maximum value, how we can get? We will take this term, this containing square, x minus h. This one, this we will take equal to 0, then x will be equal to h. At x is equal to h, then this function will gives us f of x. when x is h minus h 0, this whole term will be 0. F of x will be equal to k. F of x will be equal to k. This k will be the maximum value of this function. F of x equal to k is maximum value. If a is positive, means greater than 0, then this turning point hk is the minimum point for this minimum point. Suppose here we are taking this x minus h, the base of term that is having square 0, then at x equal to h, x minus h will be 0, x will be equal to h. At x equal to h, function f of x will be equal to k, and that value of the function is the minimum value, is the minimum value of function f of x. Now we are going to start exercise. Exercise 2.2 is question number 1. Use the symmetry of each quadratic function to find the maximum or minimum point. Sketch the graph showing all the axis crossing points. First part here is given. Exercise 2.2. It's question number 1. Part A. That is y equal to x square minus 5x minus 6. X square minus 5x minus 6. This is the quadratic function. First of all, we will find maximum or minimum point. How we can know that point will be the maximum, turning point is maximum or minimum? That is from coefficient of x square. As coefficient of x square is a 1, and you know 1 is greater than 0. A greater than 0 means positive. Therefore, turning point will be the minimum point. Therefore, turning point is minimum point. Now we will find the minimum point. That what is minimum point. For that we will make here the perfect square. Y is equal to x square as it is minus 2 into a. A here is x. We will make the form a square minus 2ab plus b square. Okay. A square is x square minus 2 into a. Already we have taken x. B what we will take here. As here is minus 5x. Then we will take here 5 divided by 2. You can see this 2 cancel with 2. Then 5 into x is 5x. B here is 5 divided by 2. Then plus b square plus b square. Then here b square means 5 divided by 2 whole square. After that, is this as it is. This as it is. This minus 6 is remaining. Minus 6 we will write, and this is extra. 5 by 2 whole square we are writing extra. Then we have to subtract the same. 5 divided by 2 whole square we have to subtract also. Now we will simplify. y is equal to, here is a square minus 2ab plus b square. It means this is a minus b. B is 5 by 2 whole square minus, these two are outside the square, minus 6 and minus 5 square divided by 2 square. Then we can write 6 minus 5 square is 25 divided by 2 square is 4. That will be y equal to x minus 5 by 2. We can write 2.5 whole square minus, here minus we can take common, all by 4. 6 sets are 40 and minus is common. 46 4s are 24. 24 plus 25 is 49. Okay, we are taking LCM here. Okay, you can take minus common, then after that 6 plus 25 by 4, that will be 49 divided by 4. Then y will be equal to x minus 2.5 whole square minus 49 divided by 4. It will be 12.49 divided by 4, 12.2. 12.2. This is the form y equal to x minus a into x minus h whole square plus k. Then h here is 2.5 and k here is minus 12.2. These are the values of h and k, mean the turning point. As turning point will be the minimum point, then minimum point here is 2.5 and minus 12.2. This is the minimum point. Now after that we will check the intercepts. What is the intercept? From where curve crosses the axis. You know, when curve crosses the x-axis, there y will be 0, and when curve crosses the y-axis, there x will be 0. First of all, we are finding the x-intercepts. For x-intercepts, you know, y will be 0. This is, you can say, this equation number 1. Here, y is x square minus 5x minus 6. X square minus 5x minus 6, this will be 0. From here we can get two values of x. Those will be the two intercepts, mean where curve is crossing the x-axis. How we can break this middle term? X square, here middle term is minus 5x and then minus 6. We can do like this, minus 6x plus x, minus 6 equal to 0. This 5 minus 5x is minus 6x plus x, minus 5x. Okay. When you will take the product of middle two terms, it should be equal to the product of first and last term. This is the way to break the middle term. Now x we can take common. Here will be x minus 6. Then plus 1 is common. Here will be x minus 6. Then x minus 6 is the common factor. Inside will be x plus 1 is equal to 0. When x minus 6, 0, x will be equal to 6. When x plus 1, 0, x will be equal to minus 1. These are the values on the x-axis, mean x-intercepts. You know, at x-intercept, y-coordinate will be 0. Here x-coordinate is 6, y 0. And here x-coordinate is minus 1, y0. These 2 points are on the x-axis. Now we will get the point where curve crosses the y-axis. Where curve crosses the y-axis. That will be for y-intercept, x will be 0. That we will put here in question 1. Question 1 implies that y is equal to 0 square. X is 0. 0 square minus 5 into 0 minus 6. Then y will be equal to minus 6. It means y-intercept here is x0 and y minus 6. It means on y-axis, the point is 0 minus 6. Now we will sketch to sketch this, this is XY plane. This is XY plane. First of all, we are drawing turning point. Okay, as turning point in the beginning I found, and that was the turning point was 2.5 and minus 12.5. Turning point was mean HA. 2.5 and minus 12.5. This was the turning point. Okay, first of all, we will sketch the turning point, coordinates of the turning point. 2.5. Suppose this is 1, 2, 3, then 2.5 will be here, and minus 12.5. So this is 5, 10, 15, and 12.5 will be minus 12.5 downward, will be here. This is 2.5 and minus 12.5. This is the turning point. Now after that, on x-axis, 60 and minus 10. Minus 10 will be this one. 60, 1, 2, 3, 4, 5, 6. This point can be 60 here. 60. This is minus 10. Now point on y-axis, that is 0, 6. 0, 6 means x0 by 6 by 5 here. 6 will be here. Now we will join all these points. How we can join? Like this. Okay, it means here sketch of the given quadratic function is this one. This is the sketch of the given quadratic function. Now we are going to do last part of question number 1, that is part F. 15 plus 2x minus x square. Y equal to 15 plus 2x minus x square. First of all, for the turning point, we will make the perfect square here. Make the perfect square this 15 as it is. From these two we can take minus common. Here x square will be positive and 2x will be negative if you are taking negative sign common. Then y will be equal to 15 minus, inside a bracket here we will make the perfect square. A square is x square. Minus 2 into a is x. B we will take 1 because here is 2x. 2x into 1, 2x. B is 1. Then b square is 1 square. 15 as it is, x square as it is, minus 2x into 1 minus 2x as it is. This 1 square is extra, but this minus also multiplying with this. It means this minus into plus minus 1. Minus 1 is extra. Then we have to add 1 also to balance this function. Okay. Now y is equal to this 15 and this plus 1 is 16. Minus inside the bracket, that is the perfect square, x minus 1 whole square. This is the form a into x minus h whole square plus a. Here the turning point is hk, x minus h. H is 1 and k is 16. Turning point is this one. Now after that, we will find intercepts on axis. First of all, we are finding X intercepts for points on X axis, mean X intercepts. You know, y will be 0 and y is this one. Here 15 plus 2x minus x square is equal to 0. Throughout we can multiply with negative sign, x square minus 2x minus 15 equal to 0. Okay. Then we will break the middle term here. X square. First and the last term product is 15x. And middle term is minus 2x. Minus 5x plus 3x. We can break in this way. Look, minus 5 plus 3 is minus 2x. When we will multiply these two, product is equal to of these two. Then x we can take common, here will be x minus 6 plus 3 we can take common, here will be x minus 5, here will be x minus 5 equal to 0. Then x minus 5 is the first factor. X minus 5 we can take common, inside will be x plus 3 equal to 0. When x minus 5 0, x will be 5. And when x plus 3 0, x will be minus 3. X will be minus 3. It means 2 points on the x-axis are 5 and 0, and the other point is minus 3, 0. These 2 points. Now after that, you will find the y-intercept. Y-intercept will be into here. For y-intercept, you know, x will be 0. X will be 0. We'll substitute here in this equation, equation 1. Y is equal to 15 plus 2 into x 0 minus 0 square. It means y is 15. Then y-intercept is 15. X 0 and y 15. This is the point. Now we will sketch how we can sketch the graph. Turning point is 116. Turning point is 116. That is x1, y suppose 5, 10, 15, and here will be 16. 116 can be here. This one is the turning point. 116. Now on x-axis, 2 points are 5, 0 and minus 3, 0. 1, 2, 3, 4, 5, 0. And minus 1, minus 2, minus 3, 0. These 2 points are on the x-axis. On y-axis, 0, 15. X 0, y 15 is here. This point is 0, 15. Now we will join all these points. How we can join? This one. You can see here coefficient of x square was negative. Therefore, this turning point is the maximum point. And this 116 is the maximum point. Now, after that, question number 2. Question number 2 is, express each of the following in the form x minus m whole square plus n. X minus m whole square plus n. In this form, we will convert all the parts in question number 2. First part here is x square minus 8. Part A here is x square minus 8x. X square minus 8x. How we can convert in this form, as this is x minus m whole square, mean the perfect square. We will convert in the form in perfect square. That is a square is x square minus 2 into a. Formula you know, that is a square minus 2ab plus b square, or a square plus 2ab plus b square. Okay, a square is x square minus 2 into a already we have taken x. B what we will take here? We need here 8x. 2 is already here. If we will take b 4, then 4 2s are 8x. Okay, and b is 4. B square means 4 square. Is x square as it is, minus 4 2s are 8x as it is, then plus 4 square. 4 square is extra, then we will subtract this one to make this Bell's form. Up to here is a square minus 2ab plus b square. A minus b whole square, x minus 4 whole square. And this 4 square is 60. This is the form x minus m whole square plus n. This is the required form. Then last part of question number 2 is x square plus 3x. Part H. X square plus 3x. How we can make perfect square here? A square plus 2 into a already x is here. B what we will take? As here in the question is 3x. Question is 3x. B what we will take to make 3x, then we will write here 3 by 2. You can see 2 cancel by 2, 3x. At the place of 3x, we can write this one. But this is in the form also 2ab. Plus b square. B we have taken here 3 by 2. B square means 3 divided by 2 square. This as it is. This 2 to cancel, 3x as it is. This is extra. Then we have to subtract this extra thing. Then up to here is perfect square. A square plus 2ab plus b square. A plus b whole square. A plus b is 3 divided by 2 whole square. Minus this is extra. 3 square is 9 divided by 2 square is 4. Then we can write this one. X plus 3 divided by 2 is 1.5 square minus 9 divided by 4. That will be 2.25. 2.25. This is the form x minus m whole square plus n. This is question number